Hey everybody. What our goal is in this unit is to learn how large molecules have structure and function. So large molecules like proteins and nucleic acids and things like that. But where we have to start with are smaller portions of those. So starting with sugars or amino acids, which you may not know what they are yet, but we're going to get there. So the question is, how do you get these little Lego pieces? What are these little Lego blocks that you can stick together to form pretty cool structures? And so what we're going to start with is just carbon and then say, what can you add to it? Because if you just start carbons and hydrogens, you end up with, something made out of the yellow Lego brick. Just 2x4 after 2x4 after 2x4. You end up with something boring. We'll talk about those. Those are called starches. But what we want to get to is something really cool, protein. So we're going to start with things you can add to carbons, and we're going to call these things functional groups. And again, I'm using high technology here, little handheld whiteboard. So the things you can add to carbons, we're going to call functional groups. All right. And the first one you need to know is just adding an OH group. That is called a hydroxyl. And hopefully you realize that over here, this thing here that is a hydroxyl added to a carbon. So that's going to be a C to an O and then an O to an H. That's going to be polar. The more of these that you add to a molecule, the more polar it becomes, the more soluble it becomes. Okay? If you take a bunch of carbons and add OHs to every single one of them, basically you've got a sugar, something one atom away from being a sugar. Okay? So again, this is called a hydroxyl group. You put it on carbons and you get something more polar. In fact, most of the stuff we're going to look at are polar groups because most of our organic molecules are quite polar. The next one is called an amine group, and that's the NH2 right here. So NH2 is an amine group, also polar because it's C to an N to an H, N to an H. All right. Third one, this is called a carboxyl or carboxylic acid group, and I'll explain that in a bit. Again, polar, C to a C, C to an O, C to an O, O to an H. Lots of polar covalent bonds, high polarity here. SH, this is called a sulfhydryl group, relatively nonpolar, relatively, but it's moderate. Okay? And then there's one more we'll talk about another time called a phosphate group, highly charged, not just polar, but truly charged. So we can start adding these two different carbons and seeing what kind of Legos we can make out of them. Again, you don't want just the brick. You want to have like the hinge and the spinners and the axles and wheels, all sorts of cool stuff. So I can modify this a little bit, but we'll add more later. These are just the things you can add to the bricks. Okay, so we're starting with this. So to angle this up, so here's our central carbon. We're just going to start with one carbon. Nothing more complicated than that. So one carbon, and we're going to start adding extra stuff to them. So here we're going to add on one side, we're going to add something called an amine group. And if you remember that from the last couple minutes, that's an NH2 group. So we'll add that over here. So add an N and an H2. So N, and then it's bonded to two hydrogens. And I'll draw them like so. Okay. And stuff might not show up on this board especially well. I'll do the best I can with the markers that I have. All right, so there's an amine group on one side. On the other side, I'm going to add a carboxylic acid group. Could I have chosen something else? Sure. Could have put a sulfhydryl, could have put a hydroxyl group, could put anything I want. All right, but I'm going to put over here a carboxylic acid group, or you could just call it a carboxyl group. And here we go. And we'll see if this shows up. So this is a C, double bond to an O, and then an O and an H. Okay, so this is a carbon. On one side, it's bonded to an amine group. On the other side, it's bonded to a carboxyl group. If you remember, carbon is actually bonded to four things typically, makes four covalent bonds. So I've drawn two of them. This one going backwards in that direction, that's going to have just a hydrogen on it. And the one up here, we'll talk about that another time. So why did I draw this? Again, I could have put a hydroxyl here. I could have put a sulfhydryl here. Could have put a phosphate up there. It's like, why am I drawing this? Well, I just took a carbon and added an amine and a carboxylic acid. I add an amine and a carboxylic acid. I add an amine and a carboxylic acid. An amine This is an amino acid, folks. All right, so every single amino acid out there has essential carbon, and on one side you've got an amine group, or an amino group, if you want to call it that, or on the other side you have a carboxylic acid group, or just called an acid. So an amino acid is any carbon with an amine on one side, an acid group on the other side, you've got an amino acid. But it turns out there's lots of them, right? In a textbook, you'll learn that there are 20. In reality, there's 20 really common ones that are genetically encoded in organisms like ourselves. So how are they different? Right there. Right up there is where they differ. So an amino acid is going to have any one of 20 or more versions up here. And that's what makes them different. What I mean by that is every single amino acid is going to have the same structure here. So that's just going to make, a chain. So if you take a bunch of amino acids and you string them together, sure, you get a straight line something or other. But up here, what if this thing up here is polar? What if it's nonpolar? What if it's large? What if it's charged? Each one of those gives a different property, and that's when you start creating bonds between locations of an amino acid polymer. So again, a polymer of lots and lots of these things put together is called a polypeptide, which when folded up into something that does something is called a protein. And so the properties of the different amino acids are what matter. And I'll just give you one example to connect this with sort of genetics a little bit. So I could put something in one location. This is an amino acid right here. On one side of it would have been the amine group. On the other side would be the carboxylic acid group. And this is up here. This is called the R group. And I just put one of the various types of R groups. And down here, here's another amino acid. The carbon's here. The amine's on one side. The carboxyl group is on the other side. We'll get into more specifics later. And then there's an R group sticking out of it. And when we start folding proteins, what we're going to learn about is, well, if this one happens to be negatively charged and this is positively charged, hey, maybe we can start to form bonds. In that case, an ionic bond. If they're both polar, you might be able to form a hydrogen bond. And there are more and more complexities that go along with that as we progress. But the starting point, an amino acid is essential carbon with an amine group and a carboxylic acid group. There are 20 most common amino acids that are genetically encoded, and they differ in this region up here, which you can call a side chain or R. That's it for today. See you next time.